Alright, today we're going to look at how we deal with forces acting in an object that are not horizontal and vertical anymore. So in class we've actually got an object that's hanging from a string, and it's a mass, and then we've got two additional strings that are holding the object up hung from the ceiling. So our mass is going to be 0.5 kilograms, okay? And these two angles, we're going to have one angle at 50 degrees and let's say one angle at 30 degrees. And we want to find the tension in each of these ropes. So tension 1, actually let's call that tension 2 since it's for angle 2, and tension 1 since it's for angle 1. Alright, we can see that we're going to have, hopefully see that we're going to have forces that are going to add up to a net force of 0. And it has to be a net force of 0 in the x direction because we can see that there is no acceleration, right? The box is not swinging around, point P is not swinging around. And there's no acceleration in the vertical direction either. So we're going to be able to write two equations. We're going to write about the net force in the x direction, adding up to 0. And we're going to write about the net force in the y direction, adding up to 0. And specifically, we're going to look at a free body diagram for point P. So over here, I'm going to go ahead and draw my free body diagram, and I can see that I've got three forces acting on point P. I've got one force going straight down, and that's going to be equal to m times g, or 0.5 kilograms, times 9.8 meters per second squared. I've got another force that we've called T1, and I've got another force that we've called T2. There's my free body diagram. What do I do after I draw a free body diagram? I write F net equals ma, but I'm going to be a little more careful with how I'm writing it now because I've got to write it twice because I've got forces acting in the x direction and I've got forces acting in the y direction. So I'm going to take a look at my y direction forces first. Okay. Now, a couple of things, a little geometry here, just because it's easier to see. If this angle right here is 50 degrees, then I also know that this angle right here is also going to be 50 degrees. And this angle right here is also going to be 30 degrees. So make sure you look at your geometry. Basically, we've got parallel lines, right? So this line right here and this horizontal line right here are going to be parallel. And then this is a transversal, and we know that these vertical angles here and here are going to be equal. Same thing on the other side. This line and this line are parallel. This transversal means that this angle right here and this angle right here are going to be 0. So now that I've got that, I can go ahead and I can look at my forces in the y direction. Well, the first force that I have in the y direction is from T1 right over here. But it's not all in the y direction, so I have to find the component of T1 in the y. Well, we've done that a whole bunch of times, and we know how to do that. We know that the component of T1 in the y is simply T1 times the sine of 30 degrees. Make sure you understand where that comes from, okay? Make sure you understand that we just got that component from this angle and the magnitude of T1, which we don't know, so we're just calling T1, okay? I left it positive because T1 is pointing up and to the right, and I usually assume that up is going to be positive, okay? Now to that, I'm going to go ahead and add another force because I've also got T2, a component of T2 in the y direction, and that's going to be T2 times the sine of 50 degrees. Okay, so I've got T1 times the sine of 30 plus T2 times the sine of 50 degrees, and then that's going to be positive as well because T2 is acting up. And then I've got a third force acting in the y, and it's this force of gravity, and it's all in the y, so I already know the component because the entire force is acting in the y direction. I can do a little mental math, and I know that 0.5 times 9.8 is simply 4.9 newtons. So adding up all of those forces comes to 0. Now let's take a look at what's happening in the x direction. So my net force in the x direction. Well, I don't have to worry about the force due to gravity because it's all in the y direction, but I do have to worry about my two tensions, T1 and T2. So T1 in the x direction is simply going to be T1 times the cosine of 30 degrees, and that's going to be positive because T1 is pointing to the right. And then I'm going to look at T2, and the component of T2 in the x direction is going to be T2 times the cosine of 50 degrees. And those two have to add up to 0. Now, why did I make T2 negative? Because T2 is pointing up but to the left. and we assume that right is positive, left is negative. So T1 is positive in this case, T2 is negative, the component in the x direction. So looking at this, I can see that I've got two equations and I have two unknowns. The only two things I don't know are T1 and T2. So you can use a system of equations pretty easily to solve for T1 and T2. The way I do this, and everybody has a kind of a different method, but the way I do this is I solve this F net in the x direction equation, and I'm gonna solve that for T2. And I'm gonna say, well, T2 must be equal to T1 times the cosine of 30 degrees divided by the cosine of 50 degrees. And I can plug that into my calculator if I want to make things a little bit easier to write. And I find that T2 is equal to 1.347 approximately times T1. Of course, I'm not going to approximate in my calculator. I'm going to carry out the significant figures. But when I write it, it's easier to write it that way. Okay. Then I'm going to go ahead and I'm going to substitute this in to the first equation, which is my F net in the y direction. And I'm going to get the T1 times the sine of 30 degrees plus T2, but instead of writing T2, I'm going to write what I got here. And I'm going to write plus 1.347 times T1 times, that was just T2, times the sine of 50 degrees must equal, and I'm just going to bring this 4.9 over to the other side, must equal 4.9 newtons. The rest is just some algebra. I'm going to go ahead and I'm going to factor out T1, and I'm going to take the sine of 30 degrees plus 1.347 times the sine of 50 degrees equals 4.9 newtons. And then you can go ahead, plug all that into your calculator. And why don't you do that now? Pause this now. Make sure you get the right answer for T1. Okay, go ahead and pause. All right, when you come back, you should see that T1 is equal to 3.20 newtons approximately. Great, now I know the tension in that first rope. The tension in the second rope I get from my equation that T2 is T1 times the cosine of 30 degrees over the cosine of 50 degrees. So go ahead and plug that into your calculator, see what you get for T2. You should have gotten that T2 is 4.31 newtons. We now know T1 and T2. That was our goal. That's it for our notes today. Have a great day.